I shared my screen, right? Okay, so we're good there. Okay, so let's talk. We're just going to talk about this one, and I'm giving you the rest of the time to do your study guide. Okay. All right, so this was I only gave you one problem because you got to do 4 different understandings of is it absolutely convergent, conditionally convergent, or divergent, right? And it asks you how many, and then we're conditionally convergent, and then you had to categorize it, okay? It may or may not look like that tomorrow, right? It might just be a multiple choice that says absolutely convergent, conditionally convergent, or divergent, right? That's a possibility, all right? Doesn't mean it will be, it's just a possibility, okay? One thing you should notice about all of them is they all look like they're alternating, correct? Do you see the hidden alternating one on number 2? We talked about that when we were doing alternating series. We said, hey, when you have the cosine of pi n, that's another way to write negative 1 to the n over 3 to the n. Okay? So that is, they all have that alternating piece. That doesn't mean we're necessarily going to use alternating on everything. We could, okay? But it doesn't mean we're going to do that. So there's a difference between taking the absolute value of the series and doing an alternating series test where you do the absolute value of the series as the first step, okay? So that's a different thing, and that's where I think our disconnect was. Because when Ellie and I were talking about it, I'm like, oh, I realized that's like something that I wasn't very clear on, okay? So this first one here, okay, I'm just gonna start absolute value, because if I get absolute convergence, I know I don't have to do any other testing. Okay, or if I get divergence, I do have to keep going. But if I get absolute convergence right away, I don't have to test anymore. Okay, so I'm just going to start by taking the absolute value of each series and see what happens. Okay, so here's my work for series 1. Okay, so I'm going to take the absolute value of it right away. So I'm going to do n equals 0 to infinity. I'm doing the absolute value of this thing. Remember, this isn't alternating series test. This is me taking the absolute value of that series. So my new series that I'm testing for convergence is this one. Okay? I'm going to do one of my series tests on it, right? Any ideas on what we should use? Yeah, I used an integral test on it. Trust me, I tried everything else I could to do not an integral test, but I ended up going with an integral test. So to do an integral test, I did the integral from 1 to infinity of 1 over 2n minus 3, which I have to convert to the limit as b approaches infinity, 1 to b of 1 over 2n minus 3. That's a 1. So the tests that we had on the last quiz, right, aren't gone, right? Or on the last triads test or whatever, they're not gone. We have to do them again. But hopefully you know them, and this is good, like reinforcing you need to restudy those tonight, okay? All right, I would have to do a U substitution, correct? Yeah. What would I get out of the U substitution? A 2. So I need a 2 in here, and what do I need outside? A 1/2. So we're ignoring the blue 2 on the inside. I totally did not write dn, did I? And if you want to convert it to x's, you can. It doesn't matter. Okay. All right, so my next line would be the limit as b approaches infinity. I'm keeping the 1/2. What's the integral of this mess? Natural log, absolute value of u, or the 2n minus 3. And I'm going from 1 to b. All right, we've got the limit as b approaches infinity of 1/2 the natural log absolute value of 2b minus 3 minus the natural log absolute value of, oh, you know what, it isn't 1. Good. That's a little bit, no, it's not much better. It still comes out negative. It's supposed to be a 0. 2 times 0 minus 3. It started with a 0, so I'm going with, I know, I have too. I wrote it wrong. All right. Ultimately, when I take this infinity and plug it in there, what's this whole thing going to equal? Infinity. So what does that mean happened on an integral test? It diverges. Okay? Here's the thing. I don't know. I know that the absolute value of the series diverges. That doesn't mean that the series necessarily diverges, right? It just doesn't converge absolutely, all right? So this is a possible diverges overall or converges conditionally, okay? So I have to go through and I now need to test the series the way it looked originally, not the absolute value of it, and run a series test on it, okay? So I'm going back to my original series here. If I were just going to pick a series test without looking at absolute value of it, what series test would we pick? Yep, so now I'm going to go do an alternating series test on the same one, right? Okay, so alternating series test would state that I do the limit as n approaches infinity of 1 over 2 minus 3, 2n minus 3, which is going to equal what? Yeah, it's going to equal 0. So does it meet condition 1 of alternating series? Yeah. Yes, okay. All right, condition 2 means I need to look for what? Decreasing terms. So I'm going to start putting in numbers. So 1, I put a 1 in, or a 0 in, right? That was our first number, would be negative 3. That's not great. All right, put in a 1, I would get negative 1. It's not decreasing yet. Put in a 2, what's 2 minus 3? 1, okay. Put in a, we're up to 3, right? Put in a 3, what do I get? It would be 3, because it'd be 6 minus 3. 8 minus 3 would be 5. Are we decreasing finally? Yes. Yeah, so does it pass alternating series? So it converges conditionally. Okay? Because the absolute value of it diverged, right? And then we were able to run a regular series test on it and it converged. So this is the conditional convergence on this one. Okay? Does that make sense to everybody? Yeah. Okay. If we get lucky and it converges on the absolute, then we know it. We don't have to do the second test. Okay? All right. I'm going to keep going. This is not like a small thing, right? This is why I only gave you one of these, because you got to run 4. You got to do 4 of these things. Okay? I really debated putting a second one in there. I'm like, no, that's enough. Okay? All right. We're going to look at number 2 now. Okay? So number 2 is what I'm going to do the absolute value of it, right? So I'm going to do this series. I'm going to do the absolute value of, I'm just going to write it as negative 1 to the n over 3 to the n, which is going to look like this, n equals 0 to infinity of 1 over 3. Could I write it 1 over 3 to the n? That's geometric. Good. Okay, so if that's geometric, what's our r? 1 over 3, greater than 1 or less than 1? So I always remember it as p series diverges less than 1, right? Because the harmonic, right? So if it's geometric, it's the opposite. So what is this? What happens with this one? Converges, but not just converges, but converges absolutely, because we got the convergence on the absolute value. I don't have to keep going. I don't have to do anything else because I got the convergence right there. Okay? So this one converges absolutely. Okay, I'm going to do the third. Everybody ready for, I might be going too fast. I don't want to go too fast, but I also want to make sure you have enough time today. Okay, I'm going to go to the third one. So the third one, I'm going to do the absolute value of it, right? So sum as n equals 0 to infinity. Oh, no, it's not 0. What is it? It's 2 this time. The absolute value of negative 1 to the n plus 1 over n squared minus 1. All right, so I have this. N equals 2 to infinity of 1 over n squared minus 1. All right, what test would we run? It's not quite a p-series, but I like where you're thinking.
Is it another integral test?
No, not another integral test.
Is it a limit or direct comparison?
Yeah, we could use the limit or direct comparison. I went with direct comparison when I was doing it. So it's a BCSD one, right? Because of the P series, right? What would I compare to?
Oh, that makes so much sense. I understand. 1 over.
Right, 1 over n squared, because that means that P is equal to 2, okay? And then when P is equal to 2, it's greater than 1, so what happens?
Oh, it's P series. What? No.
Oh, no, it
converges.
Converges, okay? So that means I need this one to be the bigger series, right? Okay. Not sure that came out right when I was doing this. Let's see if it works. I'm not sure it does. All right. 1 over, because I think I may have done my work wrong, but let's try it. Okay. All right. So if I'm starting with 2, because I didn't start with 2 when I was doing it. All right. If I start with 2, we get 1 over, what's 2 squared? 4 minus 1 is 3, and this would be 1/4. It's smaller. Let's see if we keep going. I don't think it's going to help, though, because it's always going to be 1 less, right? Because if I put in a 3, it would be 1 over 8, and 1 over 8, and it would be 1 over 9. So that one failed. Let's look at, I didn't try the limit comparison. Let me try a limit comparison. Let me go look that up. I don't remember it off the top of my head. I know it exists. It was in 10.6. Comparison tests. Okay, where's my limit one? All right, so I have to do the original over the comparison, right? Okay, so I'm gonna retool. I made a mistake, right? I wasn't working good, so I'm gonna keep that though. P2. I still know that converges. I'm not gonna use BCSD. I'm gonna use limit. See what happens with limit. So limit is the limit as n approaches infinity. I want the original. My original was the 1 over n squared minus 1 over my comparison, which is 1 over n squared. All right. Middle school fractions, what do we got to do? Keep, change, flip. Okay, so keep, change, flip. So what's the limit on that going to be? What's my biggest exponent? So what are my coefficients? 1 and 1, which is going to be 1. So therefore they either both converge or both diverge. So what just happened? What kind of convergence did we get? We got absolute convergence. Okay, so we now have 1 that converges conditionally and 2 that converge absolutely. Okay, I'm gonna give you a couple seconds because I know I may have gone too fast. I'll put it back there. This is no small problem, right? This is not quick by any stretch of the imagination.
Like a normal problem that we could see in computer?
It's possible that they give you the Roman numerals. They may not give you 4 of them. They might give you 2 or 3 of them maybe. So maybe 1 of each. It probably wouldn't I don't know. I don't know where I picked the question up from. I was trying to dig and find it, and I didn't find it. Maybe it just, and it could just ask, of the 4, how many are conditionally convergent? It probably wouldn't do this thing where it categorizes that was a Mrs. Ballard thing, right? So you could check your work. Or it just says, they give you 1 series and you do absolute conditional diverges, okay? All right, let's look at the 4th one. And then I'll give you time to work, okay? All right, 4th one. I'm gonna put it down here. All right, I'm gonna do the absolute value of it again, okay? Because that's kind of where I started all of them. I'm trying to be consistent, okay? So if I do the absolute value of the -1 to the n minus 3 over 2n minus 1, okay, that would be, I forgot my series notation. It was 1 to infinity. So that would be n minus 3 over 2n minus 1. What test should I run on that?
Why is it n minus 3?
Nth term.
It's an nth term, good. because it was n minus 3 here.
I know, but you're taking the absolute value, just to get rid of the negative one.
Yes.
So nothing else changes.
Nothing else changes. I can't do like take the absolute. I can't change those signs. That's like more. It's not killing kittens, but it's along those lines. Okay. All right. Okay. So if I'm going to do nth term, because that's exactly what we should do is nth term. Limit as n approaches infinity of n minus 3 over 2n minus 1. What's that going to equal? 1, which is not equal to 1 over 2, which is not equal to 0, therefore it diverges. So we just proved divergence of the absolute. Does that mean I get to be done? No, I still need to try another test, right? Okay, so if I tried another test, what test would we do? Yes, we would use an alternating on it, or at least I'd start there, okay? Alternating series test. So that would mean I would want to do, I'm checking it, the limit as n approaches infinity of n over 3 and 2n minus 1, which we already know is equal to 1/2, which is not equal to 0. So what does that always end up meaning?
Diverges by nth term.
Diverges by nth term. So it's like a double nth term, which is really weird. But it works. So what happens with this last one?
It diverges.
It diverges overall. Okay? That was kind of brutal, and I'm sorry. All right? There's gonna be one somewhere on the AP test. I couldn't just skip over it because then you all would be mad at me in May. Okay? So this is, and again, we aren't doing this in January where it normally hits, and you guys' brains aren't ready to be back from Christmas break. Okay? So we're on the way to go to Christmas break, but I think we're in a far better place than I have been in my past years. Okay? Any other questions on this one? All right, I'm going to give you all the rest of the period to work. Okay? If you need help, that's fine. Okay? I know Annalisa wanted to use the front boards. We can put that up and use the front boards. I'm happy to do that with you guys.